What I'm going to show you today is an entirely different way of observing and measuring current, one that is more akin to measuring voltage. This is the AIM iProber 520, designed and built here at AIM TTI. The iProber measures current by simply placing the insulated tip onto the current carrying conductor without making any electrical contact. Observing and measuring current has always been much more difficult than measuring voltage. Either you have to break the circuit and insert a resistive shunt, as happens when you connect a multimeter into a circuit, or you have to completely enclose the current carrying conductor with a magnetic loop, as happens with a conventional current probe, which is clipped around the conductor. Obviously, neither of these methods are likely to be possible on a high-density PCB. We haven't managed to change the law of physics here. What we are actually measuring is the magnetic field that results from the current flowing through the conductor. That's exactly the same thing as is measured by a conventional loop current probe. However, these probes work by capturing the whole of the field by surrounding the conductor with a loop of high mu material such as ferrite. By contrast, the iProber signal is critically affected by the position of the probe relative to the conductor. What the iProber is measuring is the magnetic field at a precisely defined point in space. We call the iProber a positional current probe because the measurement is critically dependent on the position. It consists of the probe, which is connected via 1.5 meters of cable to the base unit, which is a short BNC terminated cable for connection to an oscilloscope. Power is provided via a small power adapter that plugs into the base unit. So what's inside an iProber that makes this type of measurement possible? The heart of the probe is a patented miniaturized version of a fluxgate magnetometer. Fluxgate magnetometers have been around for decades, but not in miniature form. It is the patented miniaturization that enables it to measure the field at a precise point in space. But in addition to that, the miniature sensor has a much lower noise and much wider bandwidth than a conventional fluxgate magnetometer. Users must consider all fields that will be present in the area of the probe tip. In all cases, this will include the Earth's magnetic field, which when north-south across the probe tip will present a field of approximately equivalent to 200 milliamps. In addition to this magnetic fields are also developed by wound components, metallic component parts, and also adjacent multi-layer tracks. Consideration of these adjacent fields must be taken. As well as acting as a positional probe for PCB tracks, the iProber can also act as a conventional closed-loop current probe. A clip-on toroid assembly is supplied that converts it into a conventional probe when required. In this mode, the iProber has the same bandwidth and dynamic range, but with a greater rejection of adjacent fields. So now let's look at the base box. There are 3 switches and 2 knobs. The mode switch is marked PCB track, field or wire. You set wire mode when you use the clip-on toroid to measure the current in wire or cable. Below the mode switch is the sensitivity control, which is only active in PCB track mode and is used in conjunction with the calibrator to compensate for different widths of PCB track. Above the mode switch is the calibrator. The wider the PCB track, the lower the field strength for a given current. The sensitivity control is adjusted to give 1 amp per volt scope deflection, based on the calibration graph provided. On the left-hand side is the trace position control. This is used to null out unwanted DC effects or to offset the trace on the scope. It is only relevant to DC measurements. Above it is the bandwidth switch. This can be set to full bandwidth 5 MHz or to 500 kHz to reduce the wideband noise and to reject HF interference. The third position, marked 2 Hz, is intended for DC-only measurements, where maximum possible AC interference rejection is required. In the centre is the overload indicator, which lights when currents above 20 amps peak to peak are driving the sensor into overload. The probe is light and compact and fits comfortably into the hand. The tip is made from high temperature material and the probe is double insulated for safety on high voltage tracks. The grip guard keeps your hand away from any high voltage areas on your target PCB, and the whole probe is 300 volt Cat2 rated. This concludes the first part of my introduction to the AIM iProber 520. In a second part, I'm going to show you more about the iProber in action and discuss some of the difficulties and limitations that you might come across and the various ways that you can counter them.